In this video, we're going to look at section 5.4, day 2 for pre-calc, and this one is going to be solving some logarithmic or exponential equations. So for these first ones, we're going to look at if they give us numerical values for the logs, then let's evaluate them. So in this case, it says log of A equals -2, log of B equals -5, and log of C equals 4. This does not say that A equals -2, so you can't just plug it in here. B doesn't equal -5. So what we need to do is expand this logarithm to get it into multiple logarithms so we can see these. So we see that we have this B to the 6th on top, and then we have C to the 3rd on top, and then we've got this A to the 3rd on bottom. So we're going to expand the logarithm by adding the logs on top. So we're going to do log of each of these tops, and since this is multiplication, we're going to add, and the one on the bottom, we're going to subtract. So we've got log of B to the 6th plus log of C to the 3rd minus log of A to the 3rd. And then we're going to expand even further by moving these exponents out to the front, right? So log of B to the 6th is 6 times log of B, or log of C to the 3rd is just 3 times log of C. So we'll just move this out front, and then same thing here, move this cubed for the A out front of that logarithm. So now we can see that we have 6 times log of B, 3 times log of C, -3 times log of A, and we can plug these in here. So we know that log of B is -5. So in place of log of B, we'll put -5. And then we have plus 3 times log of C, and log of C is 4. And then minus 3 times log of A, and log of A is -2. So then we have -30 plus 12 plus 6. So this is 18, and -30 plus 18 is equal to -12. So this equals -12. Second one, so again, we'll do the same thing. First thing I'm going to do is rewrite this bottom as C to the 5/2, since that's what that square root will do. And we know with logs, we want exponents. So here we've got log of A to the 7th on top. So, and then times B to the 4th. So then this will be plus log of B to the 4th. And then this is on the bottom. So we'll be subtracting log of C to the 5/2. So then we'll be able to take this 7 and bring it out front, take this 4, bring it out front, and take this 5/2 and bring it out front. And then we know that the log of A is 4, so we'll plug that in here. And then we have 4 times log of B, and log of B is -9. Whoops. And then we have minus 5/2 times the log of C, which is 6. So then we'll simplify this. So this will be 28. 4 times -9 is -36. And then here we have -30 divided by 2. So that's going to be -15. 28 minus 36 is -8. And then we have minus 15. And -8 minus 15 gives us -23 for our overall answer here. All right, then in these exponential functions, we're going to be looking to get the same base on both sides. So we're going to be looking to rewrite this base and this base as the same number. And there'll be different ways to do this. Like both of these could be written as base 2, but they also can be written as base 4 because 64 is equal to 4 cubed. So that's what I'm going to do, is write this one as 4 cubed. And so we have 4 cubed to the x plus 3 equals 4 to the x minus 1. So then we're going to use our power rule here, which tells us when we have a base and then a power to a power, that you multiply these. So we'll be multiplying 3 times x plus 3 for that exponent. And then we have 4 to the x minus 1. So since these are now the same base, we know that that means that these exponents must be equal to each other. So we know that 3 times x plus 3 needs to equal x minus 1. So we'll distribute that. So 3 times x is 3x, and 3 times 3 is 9. And then I'm going to subtract x from both sides to get these x's together. So I'll have 2x plus 9 equals negative 1. Subtract 9 from both sides. And then you get 2x equals negative 10. Divide by 2, and we get x equals negative 5. Next one, so our bases are 16 and then 256. So you can check 16 and see if you can write that as 256. So 16 squared is 256. So we'll be able to rewrite 256 as 16 squared. So we have on this side 16 to the 2x equals, and now we'll be able to rewrite 256 as 16 squared. So then now we can use the product rule. So this side is still 16 to the 2x, and then this side is going to be 16, but now we're going to multiply these together. So then 2 times 2x plus 5 for the exponent here. So now that they're the same base, we know that the exponents will equal. So we know that 2x equals 2 times 2x plus 5. So 2x is equal to 4x plus 10 when we distribute this 2 in. So I'll subtract 4x from both sides to get the x's together. So we get negative 2x equals 10. Divide by negative 2, and we get x equals negative 5. And then final one here. So we've got the base of a 9, and then we've got the 243. So then we can look at 9 squared, which is 81. You could look at 9 cubed, which is 729. So this means that we can't write 243 as a base 9. So we're going to have to look to something else. So what other bases can 9 be written as? So 9 can be written as 3 squared. So then let's check if we can get 243 as a base 3. So 3 cubed is 27. 3 to the 4th is 81. And then 3 to the 5th is 243. So these two can both be written as powers of 3. So we'll rewrite 9 as a power of 3, and we'll rewrite 243 as a power of 3. So 9 is equal to 3 squared, and then 243 is equal to 3 to the 5th. So then we'll write it as 3 and then multiply this base with this one. So 3 to the 2 times 3x plus 3. And then over here, we'll multiply the 5 and the x plus 2 for our exponent. And then we know that the base or the exponents will equal each other since the bases are the same. So then this is going to be 2 times 3x plus 3 equals 5 times x plus 2. So we'll distribute on both sides. So 2 times 3 is 6, and 2 times 3 is 6 again. I squared it on accident. Okay, so 6x plus 6, and then 5 times x and 5 times 2. Subtract 5x from both sides, and we get x plus 6 equals 10. Subtract 6 from both sides, and we get x equals 4.